Let's go.
So we've all covered the PHPP. We're fed up with the PHPP. We've heard enough about it. We mentioned that the PHPP had an add-in sheet called the PHT Summer Stress Testing. We've covered that. There is another add-in. It's called the pH ribbon, and as it is designed by Tim Martel. He's a certified glasswise designer, chartered architectural technologist, and AEC expert who is also a course tutor for carbon light retrofit, very, very much into carbon. And the appearance of your pH ribbon will vary depending on which edition of PHPP or pH ribbon you're working in. Obviously, I'd strongly encourage you to be up to date. PHPP is currently running a version 9 with the pH ribbons that works with that is the most recent one and the most current in terms of its content and evaluation. Really, from our point of view, we're going to focus on this one, which is about it's the extended version of PHPP, and it basically takes all the number crunching and all the values that we put into the PHPP, and it uses them for a different purpose, which to evaluate our carbon footprint, our carbon emissions in both the operational use of the building for a lifespan that we designate its traditionally 60 years, and the embodied carbon, which is what it takes to build it and to dismantle it at the end. So that gives us an overall evaluation of our carbon emissions, CO2 emissions. And this is extremely relevant right now with climate change, energy issues, and preserving our planet and for everyone, not just ourselves. These graphs are completely diagrammatical. They have no value whatsoever, hence not having a bottom line on them. But the idea was just to demonstrate the categories that are in the carbon analysis. And in this case, we talk about the A categories. These are the embodied categories of the carbon footprint, and they revolve around the manufacturing embodied carbon of any particular product, whether it's the sheet steel that you put on the roof, whether it's the windows and the brass, or whether it's an appliance within the building, the manufactured carbon emissions. We have transport sites, so whether it's an international import, which requires shipping, flight or lorries, etc., and what the impact of that in terms of carbon footprint is. We have the construction, as in how those products are put together, and we also have what's called the sequestered, and I've talked about this, bit of a hard word to say, that is a positive impact in reducing carbon emissions, because it's basically revolving around what that product will absorb, what carbon emissions the product will absorb. So this is all pre-completion on your project, and it's the embodied aspect of your carbon. Equally, we also have the in-use impact of the embodied construction. And there's a couple of odd ones that aren't normally added, and then there's repair. So, for example, if something needs replacing within the lifetime of the building. So, for example, you might say, well, my front door is only going to last 25 years and then it's going to need replacing for that. So I need to allow for the replacement value of a newly manufactured product. There's the cleaning, so there might be some maintenance issues or changing of filters or cleaning of aspects of the building, and the impact that it might have during its use, for example, if it contains refrigerants or things like that. Then we have the embodied C-class which is also about the actual construction. What happens to it after the lifespan of the building? Does it go to landfill? Does it get incinerated? Does it get recycled? Does that involve any transportation costs? Does it just get demolished? I can't spell today. So this is very speculative because we're not going to be there in 60 years' time to actually determine what happens. All we can do is what would be an anticipated logical use of a product. So, for example, would you take the steel frame, dismantle it, and melt it down and recycle it? Probably yes. Would you take some aspects? Would you reuse the timber? There's a list of probable or anticipated results here that are based on the LETI and RIBA standards that would be acceptable criteria to assume. Equally, we also have class D1 to D4, which are the positive impacts out of these end-of-life strategies. These are all evaluated against the National Grid future energy scenarios. These change every year based on the situation in the government and what their strategy is on how they consider the grid to perform. At the moment, we're running on UK National Grid 4, which is a falling short strategy. And this assumes that we will have a green grid. So we'll be working towards it in 13 years, and by 23 years, it will be green. Of course, this has a massive impact on our approach to renewables. So, for example, if we're installing something that has a poor carbon footprint in something like PV, photovoltaic panels, its considered use in a building would be only up to the point that the grid is green in this carbon emission strategy, because beyond that you can call from the grid and it's not having an impact on emissions. So it's been a really interesting journey for us to evaluate that actually might think something as a renewable is a good thing, but for how long does it become a good thing? What is the payback time, and how efficient is that in terms of the client's projected use of the building? The other really huge factor, we talked about EPCs as like a little graph that we could evaluate the energy performance of our buildings, and that's outdated by the PHPP, but we also have a new thing called environmental product declarations, and this is the EPD, and it's a global program for environmental declarations, and they present the transparent, verified and variable information about the life cycle environmental impact of a product or service. This is very much around carbon footprint and rationalizing the performance of products and saying this is an evaluated assessment of the footprint of this particular product. We feel quite strongly that every product should have an EPD, because actually that's the only way that you can have an equal playing field to actually assess that's the impact you're having by choosing or specifying a particular product. And in some countries, it's much more important than others, but for us, it's as a company, it's really important because it makes us accountable for the specification, the choices that we make. The EPDs are punched back into the data in the pH ribbon. We can add EPDs, we can add our own if they're not already on the list that Tim's produced, and they will give us a very confident strategy of what that product will do, which is obviously calibrated in an equal playing field way. Moving on from here, there's nowhere really to go but back into our carbon lesson and say, well, we could actually now address how those carbon issues are tackled in more detail. So I thought it was just important to understand that the pH ribbon is a little tool that really allows us to bring all of the areas, the meterages, the linear aspects of any product that we use in the PHPP to build the model of the building and transfer into an evaluated graph and assessment of the CO2 emissions of the building. Thank you.
Thank you, Claire. So, yeah, just following on from what you're saying. So, it's the pH ribbon is basically a standard for the carbon emissions that are created through the manufacture of a product.
pH ribbon isn't the standard. The pH ribbon is a plug-in to the PHPP, the Passive Planning Package. It's based on standards, which are the LETI standard and the RIBA standards for and others. The RICS, I think, has some involvement. The detail of the standards is a vast topic in itself, but the point is that it's not a random selection. It's based on the criteria that have been set by these climate change institutions.
So it's a tool that allows you to evaluate.
That evaluates against their strategy, against the future targets that we have in place, that most councils now will require us to perform to.
Yeah, so that is something that the government are looking at, embodied carbon, actually having things quantified, so they could use a tool like this to do that.
Yeah, there are other tools out there, and it's not the only one. It's just the one that we choose to use.
Yeah, and I noticed at the bottom there you've got the passive house classes. You might just want to touch on those.
Yes, I guess that was just saying that we can go for standard, we can go for low energy if the constraints of the site aren't necessary, make it possible to be a passive house that doesn't need any heating. So it's a low energy, standard. When we get into the rounds of plus and premium, it's really just a calibration of how much renewables you're using. And this is where I emphasize that actually, is it either necessary or cost effective? Because if you have renewables, yes, you can feed them back to the grid, but you're basically implying that there's an active energy requirement, and it's really important to evaluate for the client whether or not they're necessary active energies or whether actually the passive approach is sufficient in itself. So it's about us understanding, that we don't just throw renewables at everything. We evaluate with our heating engineers and with the rest of our professional team to say, well, this is the best combination for the client, bearing in mind the cost of installing it versus the use that they would benefit in line with the grid for falling short strategy for energy consumption and the costs associated with that. And then we have an benefit with a capital PH being because it's a passive house benefit, which is the retrofitting.
So the low energy passive house standard is a standard that's not quite up to a passive house standard. Passive house plus is a passive house with additional benefits from the renewable energy, and then a passive house premium is
even more.
Yeah. Got you. So yeah, I understand that John is actually working on a passive house plus at the moment. Well, he's actually on holiday now, but yeah. So you mentioned the updating of the software. I just thought you might want to touch on that, and why are they updating the software, and just go into a bit of detail on that.
So the PHPP is issued by the Passive House Institute, and it's not updated very often. You can rely on it being fairly consistent for probably another year or so yet. Version 10. The reason it's updated is due to all of these moving factors. Our targets are informed information that we get back from monitoring buildings, all of these things that the Institute is studying in great depth. I can't even begin to explain what they're doing, but they started off with a piece of software and they've moved with the times. And if you want to certify a passive house now, it would need to be in the most recent software in order to verify it. The pH ribbon equally is now updated to accommodate the new PHPP, so they both move in parallel and with the new government criteria that are constantly being freshed every year.
Yeah, and that's really what we like about the standard, is that it's always evolving, it's always developing, and as it should be. It's improving. And I also like the fact that you mentioned instead of sequestration, it means absorbed. So I like that. That's a much more simple way of it's sticking to someone like myself. That you just I find it easiest to understand. And you also mentioned in there about the grid future energy scenarios. It's interesting how that is calculated, and ultimately you could say that is only a model, and so we don't know the success of the decarbonate. Yeah, it's all
No,
speculative.
so if you were comparing two different carbon analysis reports, are they both working off the same national grid data? So if one is working off the previous one, version 3 as opposed to version 4, you won't get the same graphs, you won't get the same information. So it's just knowing that is a parameter. One doesn't need to understand it in detail to appreciate that in order to compare apples for apples, we need to make sure that we're looking at the same background set of data.
Yeah, and like the passive house planning package, the cradle to grave calculation, body carbon, it can be quite complex. However, there are experts out there who can assist you with it, take all the complexity out of it. It's not something to be scared of. You can bring it down to a real basic practical understanding so that you can appreciate how to install homes that are more environmentally kind. So yeah, let's not be afraid of it. But we've got a lot of information to consider, and we can do that through professionals.
Yeah, and if in doubt, just ask, because one of the best things about this movement is that everybody wants everybody else to understand, and it's not the old school closed book, oh, I can't ask. You definitely can ask. You can always ask Pure House, and you can always share information that we can help you to calibrate and sort out, because the mission is to make sure that we all make a difference.
And the only way that we're going to do that is by talking. So yeah, appreciate that, Claire. Thanks for your time.